Good afternoon. My name is Scott Tomlin. I'm the Senior Director at Motorola Solutions, and I'd welcome you to the Motorola Solutions Tech Talks on the cloud. We will be doing this every other week for the next few months up through the 1st of December. I'd like to thank Silicon Slopes for hosting us here. And today I'm going to share with you some of the practices we use inside of Motorola to actually scale what we do in the cloud. And allow me to share my screen here very quick. While we're going, you'll be able to ask questions on whichever platform you are on. We have people watching there, and they'll send me messages throughout, and I will respond to them as I can. So again, running infrastructure at scale. A couple of the things I want to do very first off is describe a couple of our core concepts around DevOps and SRE at Motorola. We have a I don't know if it's a unique spin, but not everyone interprets these the same way. At Motorola, we firmly believe that DevOps is a practice and it's not a team. We don't have DevOps teams generally. And the primary theory, nothing earth-shattering here. Development teams own coding and testing and deploying and operating and monitoring whatever they produce. Ownership all the way through. SRE at Motorola, this is a team that is all about making sure things don't happen twice. We own the incident process and incident management process, particularly technical incidents. We help route tier 3 support. If need be, we will do emergency engineering. We'll follow up on those root cause analysis after an incident, and then we'll embed with dev teams to ensure that these incidents and the root causes are mitigated, documented, or monitored for future incidents. And it's a little bit different than if you read the Google books on SRE, but we're finding that this helps us scale. And finally, one of the unique things that we have in Motorola is a sovereign operations team, or a SovOps. Due to regulatory issues around the type of data we do, that we manage, around public safety and government agencies, personally identifiable information, a lot of our systems can't be operated centrally from the United States. And so we have to create an operations team, an organization that works within that sovereign region. They are the eyes, ears, and hands for dev teams. They have the specific knowledge they need to troubleshoot, to debug, to actually have the rights to look at some of the data in the system. They do the incident response, they do monitoring, troubleshooting, and again, emergency engineering. This is one of our biggest challenges in scale, in the fact that most regions that we go into, we actually have to put boots on the ground inside of that region to help us with that. But wanted to ground on these three kind of themes before we got going, because they kind of blend into the topics as we get going. So next, I actually want to paint for you the size of the elephant, or elephants, that we end up eating every day here at Motorola. Currently, we are supporting about 3,000 engineers developing product. They're doing this from 10 or more countries. I counted 10 real quick this morning. I'm sure I missed a few. This is about half of engineering staff inside Motorola, so this number is still growing. We have over 1,300 source repositories, 360 deployable projects. Projects can be anywhere from a single microservice to a full-fledged application, depending on the architecture and how they want to deploy that. 13,000 pods as of yesterday in our Kubernetes clusters, 1,600 VMs, 10 different environments, currently in 4 different countries. We'll be in about 8 next year. We have 10 different database solutions, SQL, Maria, Couch, Mongo, you name it. We're using it internally. We have 350 different databases where we store data. And again, most of this data is very, very sensitive. So there's all sorts of unique access rules that we have there. We support 10 different programming languages. It'd be great if everyone in the world just used JavaScript or Java or C#, but we've grown beyond that as an industry, and it creates some unique challenges for us. We have about 20 different third-party pieces of software and SaaS integrations that we support on a regular basis. This frequently comes up when we are dealing with some of our regulatory issues, because all of a sudden this third-party and SaaS software has to be brought into our compliance boundary. We have at least 4 different operating systems that we support. You know, every protocol you can think of. We have transactional systems, streaming systems, as well as real-time voice and video systems. You can think of this as our radio voice or 911. And then we have our big data and analytics platform. So that's all we're doing. But this has taught us a few lessons in how to go about things, how to make sure that we can scale in a cost-effective way for the company, and not have to hire an engineer and a DevOps person, which doesn't exist, it's a philosophy, for every time. Here's my dungeon crawl team. This is the organization that I run. We have 8 dedicated SRE engineers in 2 different countries. Well, technically not 2 different countries today, and we have 4 sovereign operations engineers so far, again in 2 different countries. So we're just at the beginning of what our sovereign ops is going to look like. We have 9 people that are just doing hosting and ingress and egress, making sure that we can support all the scenarios. 4 engineers focusing on observability. We'll talk a little bit more about that, but there couldn't be anything more important in the cloud than how you leverage your observability platform. We have 5 people focused on security and compliance. Again, as I mentioned, we handle a lot of sensitive data, so you can imagine all the rules and regulations that we have to comply to. For those who've gone through a SOC 2 audit, I miss those days. FedRAMP, ITSG 33 are examples that we comply to that just make the SOC 2 process look warm and fuzzy. And then we have 23 people focused on our authorization and authentication systems. It may feel a little out of skew, but if there's one thing that's hypercritical for what we do, and what I think most people do in the cloud, is to ensure that your data access is managed properly, and it all starts with auth-in and auth-c. All right. All those elephants we had on the very first page, you got to take them one bite at a time. I apologize for the art on this. I'm an engineer, not an artist, or a doctor, as they say. But obviously, automate. Find something every day to automate. It doesn't need to be big. You know, sometimes a one-line script that you can run in a pipeline or hand off to another engineer can multiply. Hands-off deployment has to happen. Again, because of our regulatory problems, the number of people who can actually do anything within our cloud instance is incredibly limited. Again, hands-off operations. Our SRE team members hopefully by the end of the year, probably early next year, will lose their persistent access to the environments. They will have to go through the same process any other engineer would have to do to request temporary access into that environment. Hands-off troubleshooting, I mentioned observability. If you can't detect and determine what's going on in your application via your logs, you're not going to be able to do the troubleshooting. You're not going to be able to attach a debugger to your production system. No SSH, just flat out just doesn't happen anymore. And I see this even in the non-regulated industries. It's just the best way to invite trouble into your environment. And the other thing is fix things forever, not just for today. Write that script, check it in. It will get reused, document it, talk more about documentation, but this is very much the SRE way. You want to fix something and make it go away forever. Sorry, lost my button. Always be looking into your production environment. Audit everything. And if it's not everything, it should be everything. It not only will help with your troubleshooting, but it will ensure that you have that track record on what actually caused the change to your data, who did it, and was it actually a authorized action. Monitor things you probably wouldn't normally monitor in the cloud. A lot of people don't monitor their system metrics, memory, CPU, network packets, you name it. We always, in the on-prem world, or when you can go to your own data center, you'd always have these tools and always be looking at these, be some of the first tools you'd pull out, but we've tend to move away from them in the cloud, but bring them back. You'll definitely find that becomes valuable for you. Usage, know how users are using your system, whether this is by using a real user monitoring or metrics system like Google Analytics or Elastic RUM. Knowing this will help you build better systems. It will also help you identify what the actions that the user took that may have caused a failure or a bug to be exploited in your system. Synthetic testing, probably at least, well, I'll say this is one of the most important things. This is how you emulate the user. Have your test log in and try to do an action. If you can, have it do a write transaction and a read transaction. You can do this under a specific user account so it doesn't become part of the general population or however you end up partitioning it. But you want to make sure that all of those touch points are there and that the user can actually accomplish what they're out to get for. This, again, back in our public safety space, it is so critical for certain things to happen. 911, you have to pick up the call. You know, our computer-aided dispatch, you have to be able to send officers or medics or fire trucks where they need to go. And those are the scenarios that you want to make sure you're testing constantly. Doesn't matter if your server's running or not. It's all about that use case can be done. And monitor your security. A secure security operations center for more and more organizations is important, or working with a third party who can do this for you. There are several out there that do this. Being on the cloud clearly makes you a target. The cloud providers are doing amazing jobs to help you out, but they don't know when someone's using an exploit that you have in your software. So you need to be able to do things, maybe run some machine learning over your logs and go, hey, this is an abnormal transaction, and have someone take a look at it and go, yeah, indeed it is, because It's impossible for someone to be in Seattle, Texas, or something like that. So do that constantly. We've made monitoring to be part of our doneness criteria in our Agile process. I strongly encourage everyone to do this. This is it's oftentimes the first thing that gets cut, and it's the first thing you wish you had more of. And the best way to do that is don't call anything done until you have your monitoring done. It's hard. It's so easy to say, I'll pick that up later. And I can't tell you how many projects I've shipped with half as much monitoring as I wish I had in it. Application logging. For us, people have to be very careful about what they log. Some systems might not be as problematic here, but again, because we are dealing with data that is personally sensitive, could be sensitive to the government or another organization, could fall under healthcare laws, privacy laws, you name it. Make sure you don't put anything in your application log that your developers are going to see during troubleshooting that they shouldn't because of the regulatory constraints. This one's incredibly hard to do because there are some times that you just need that data in order to do that troubleshooting. But see if there are other ways you can do that. Log a reference to the data so you don't see the data casually, but rather you see it on specific request and under the right authority and supervision. We actually had a security incident about a year ago. It was a minor one, but we were looking at the application logs, and there was actually some FBI data that got into the logs, and so we ended up creating a security incident out of the security incident. So you don't want to make your job harder by creating an incident out of just troubleshooting. So think about chaos. We're just beginning to do this at Motorola. So I don't have a whole lot of best practices around this, but as I talk a little bit later, stuff's just going to happen, and you're going to have to deal with it. Even if you're taking a dependency on something that claims to be a 5 or 6 or 72.9 system, at some point they're either going to be wrong or they're going to be down, and you're going to have to deal with that. Pen testing, I like to describe this as this is the one time you know you're going to be attacked. This is actually intentional. You're going to do it. But again, depending on where you are and the type of product you're producing, pen testing is incredibly important, particularly around places where you have sensitive information. But even if it were just vandalism or chaos, that someone may want to cause, you don't want, we don't at Motorola want to have any of that chaos or disruption happening in our mission critical systems. So always be looking. Incident response. Forest fires are very apropos right now. The one thing I will say about incident response, automate as much as you can. If you know when this type of incident pops up, you're going to restart a pod or tear down a pod or restart a service or kick a database, all the classic things we can do, you can script that. There's no reason to wake anybody up in the middle of the night to restart a server. The cloud makes that simple. Well, it makes it easier. Monitor your alert system. Make sure that your alerts are actually working. One of the points of failure that you may actually have is that, in our case, PagerDuty could be down. What's your backup plan? How do you raise people on that? So monitor that. And then more than anything, test the monitors. Make sure that the monitors are detecting what they are supposed to be detecting and that that alert is getting to the right destination. And the last 3 bullets here are the ways to do it. Playbooks are going to be necessary. I would love to be able to think about playbooks as the thing you do only when you need them. But as we discover, there are going to be some things that just need more documentation. around so that the first line, the first responders, if you will, to the incidents can actually triage and work the problem more. The last two is practice. Do your game days and do your tabletops. You take a look at this picture. These fire people here know their job before they even get there. They know what to do. They know how. They know what their role is going to be. They know what their role has to do on site. They know how to communicate with each other, and they've practiced it, constantly throughout their career. And the same thing has to happen when you're running software. Do your practice, or you're going to sound like me on the base. Just terrible. Okay, security and compliance. As I mentioned a couple times already, data protection is job one. Data breaches are what makes the news, whether you're Amazon, whether you're Microsoft, whether you're Netflix, the bank, local mom and pop grocery store. Data is what people are after, and it's where a lot of exploit and damage can actually be done. So make sure that you have a really good data management process, even if you don't have to meet specific standards or certifications, although more and more of us, at least in the US, need to be looking at ISO and SOC 2. The other regulatory standards become a lot more industry specific, but do it up front. Security and compliance, again, just like monitoring, is not the last thing you do. It should be the first thing you do. Test your security as you progress, as you're developing your software, as you're designing your systems, so that you know for a fact that they are meeting the targets. Auditors will come in and ruin your day no matter what. We love auditors, but they're always going to find something. You just don't want to make those the hard things. Let them come in and tell you need to write 2 more sentences in some disclosure or something like that, but don't have them come in and say, man, your architecture doesn't do this at all. So last thing before I jump into kind of a shift of topic is to be a champion and not a hero, particularly in the ops, the IT, the DevOps, SRE world. It's very easy to be the hero. Jump into the fire, put out the fire, and then go to bed. I'd much rather have a champion here, be Mr. Miyagi. Teach and train your partners, your dev teams. This will pay off. And we do this right after this slide. I think I'll jump into actually one thing I do with dev teams before they even start coding. Just ground them in the concepts that they need to be thinking about, and I'll share that with you guys here momentarily. Document. Our wiki is growing by like 10-15 pages a day, which is great. But the second part is you need to let people know how to find it. You need to announce where there's documentations, where there's changes. This is the hard part. Our organization, it's really hard for 4 or 8 people to reach out to the 3,000 developers and make sure that they not only know that something's changed, but have actually read it and understand it. We're still growing through that process. We're getting better at it every year. This time last year, our wiki had 4 pages on it, and we're several thousand, multi-hundreds, might be over 1,000 pages at this point. Demonstrate. Do those webinars, tape videos, something. Sometimes a 3-minute video that people can download and watch at their leisure can save you hours and hours of meetings. It's something that you can hand to teams. Hey, go watch this first, and if that doesn't answer your question, let's schedule that meeting, schedule that in-person training, do whatever it needs to be. Welcome inner source. your dev teams are your partners. And sometimes, you know, they're snowflakes, not because they're precious and melty, but because they're unique and they have a very specialized problem. And we want them to be able to contribute to the solution if they know what the solution is. Use proper, you know, pull request patterns and all of that, so no one, you're not just checking in code willy-nilly, but welcome that in. It's the best way to grow your SRE and your DevOps practices, is to get more and more people contributing to them. And then again, as I mentioned, partner and practice with the teams. This is, we embed with teams. We have embedded SolveOps people, a couple of our teams. We have, you know, the classic matrix organization, dotted lines that report into our infrastructure organization. But these are all ways to be able to partner with your engineering teams to hit that common goal. All right. So with that, I want to share with you a presentation that I've done a few times internal to Motorola. We finally decided to record it, so I haven't done it as frequently. But this is designed for the developers, the testers, even our you know, if you have a DevOps engineering org, this would be great for them as well. But these are just a few concepts that help people ensure that they're making the most out of the cloud and don't get surprised the day they ship. And I'm not going to apologize for how pretty these slides are. Somebody helped me put these together, so that's why they look radically better than the first dozen slides that we just went through. But first and foremost, when you're in the cloud, whether you're on-prem, whether you're creating a packaged product, it doesn't really matter. Understand your customers. Understand how they use your service and product. Every engineer should understand that. As you start to know that and get into that, you won't be surprised by use cases or customers complaining, why is this taking 65 minutes for me to log in? It shouldn't take me that long. And we discover that they're using a teletype machine or something like that. But understand that. Own your product, own the lifecycle, own the deployment, own the operations. This is that DevOps philosophy. Again, from the very beginning, this should just be the way you start your project. It sounds daunting at the very beginning because there's a lot of things that you probably aren't used to doing. But tackle it like a software problem, test it like a software problem, and manage it like a software problem. Engineers like to solve problems, and that's what deployment and operations are. It's just a constant feedback loop of problems. You have to consider your data. I talked about the data sovereignty and residency. Two little nuances there. Data sovereignty is a regulation that would prevent data from being exported against some boundary. For example, Canadian personally identifiable information cannot be exported outside of Canada without certain, with some certain exclusions. But and that creates some interesting problems, because that creates a situation where you can't necessarily operate from across the boundary. Data residency is that the data must reside within a boundary, but it can be viewed from across that boundary. There are countries where this is very applicable, and it's also a pragmatic aspect as well. And it does enable a lot of operations across that boundary. But huge one, will affect the way you do your data system and data access tremendously. So core concepts to know very early. Encrypt at rest and in transit. This is just table stakes anymore. People assume in the cloud this is happening. There are going to be several strategies you may want to do with this. Encrypting in transit is generally pretty simple. It's very obvious between a browser and a web server. That's going to be encrypted over SSL, and it's going to be just fine. But for us, our regulations are any data within the cloud must also be encrypted in transit. Using some of the past solutions, this happens pretty much free. Again, it's over TLS, but intra-pod, are you using a service mesh to do this? Or do you need to have some other protocol between servers to ensure that you have that encryption? Again, pretty significant design impact, so very important to know very early. You have to assume there are bad players, whether they are internal or external players. The less trust you have, the safer and the easier it is going to be to protect your data. I don't want to make this, don't trust your coworker, but intent may not, we use the word intent, but it's assume bad actors. Sometimes those bad actors are engineers meaning to do well that do a mistake. For example, this happened to us 2 months ago, I think. We accidentally deleted our jail management software in production. We had a bug in one of our systems. Someone attempted to fix it, and the whole system literally deprovisioned. Humans make mistakes. So assume that that's going to happen. Assume your data center is compromised. There isn't a day that goes by that I get some security alert from some attempt from Azure or from our other security tools around some compromise. It's just going to happen. And it's getting better. Microsoft, Google, Amazon are all making huge investments to protect their system, but they can't protect it from people who have keys to the kingdom. So yeah, trust no one. Design for progressive rollout and roll forward. The bigger your deployment and the more complicated your deployment, the more likely it's going to fail. This is the whole concept behind microservices. Ship small things, it's easy. Until all of a sudden you have 1,300 small things and they all have related dependencies on each other, whether it's runtime, whether it's data format, or whatever. All of a sudden what was simple now became very complex. So you want to make sure you can roll forward and roll backwards. Make sure you test that constantly. Try to release things that are independent. Again, microservice concept here. If this is really more aspirational. I don't believe that there truly is a microservice that is completely independent unless that is the only thing you have in your entire system is one microservice. But you're going to have dependencies on databases, and you're going to have dependencies on other components writing to a database, and all of that. But the smaller you can make that impact area, the better it's going to be, the easier it's going to be. Designed to experiment. Don't just ship features and then hope they work. Have a way to experiment. Feature flags, great way of doing this. A/B tests, a lot of strategies out there. But back to understanding the customer. Customer may surprise you in a use case. You put a new feature out, you actually don't know how they're going to use that. You know how you want them to use it, but let's test it out and see if we got that right before we roll that out. And the last thing on this one that I like to talk about is to F that app. Frequent and first, fast testing. It doesn't roll off the tongue, but you kind of get the point. Test from day one. Unit tests, integration tests, synthetic tests. I worked with an engineer a few years ago. He would always write his synthetic tests first. It didn't make sense to me then because I hadn't completely been baptized in this, but to be able to know that end-to-end scenario actually works. Yeah, your service works, that's fine. But again, that's not valuable to the customer. does that scenario work? Different ways you can go to the cloud. A lot of the cloud providers like to say, lift and shift. That's a first step into the cloud. True. Lift and shift can be a quick way to get to the cloud. It could also be a very expensive way to get to the cloud. And depending on your strategy and your needs, it may be perfectly legitimate, or not. A lot of companies, since the whole COVID incidents, are really looking towards that lift and shift. How can I get out of the physical dependency of my location so I can continue to enable my business? So that's becoming a very common way of going. It's not always easy, but it's a way. Cloud native, clearly use the PaaS, use the IaaS, do what you can to use things out of the box. You can go containerized, you can go VMs, you can go serverless. There's a variety of ways to go, and they should all be evaluated for what's going to be right for you. Do you want to manage scale up and scale down? Would you rather have a container hosting solution manage that for you? Do you want to manage the size of your VMs and balance those across the cluster? All things that would go into you making these decisions. Assume things are going to fail. This is the one thing that I can guarantee will happen in the cloud. Something will not work when you want it to. It could be big. These don't happen very often. I was just talking to the Azure folks the other day. Azure has never failed a data center. They've had some big failures, but they've never considered a data center failed. So I always tell my team, that's the last problem you need to solve for. The first problem you need to solve for are those micro failures. What if it takes an extra 50 milliseconds for your database transaction? What if the database connection failed? Or your microservice that you were connecting to failed? Or that there was a typical runtime errors. You name it. There's all sorts of little reasons that things will fail. Had a team about a month ago come to me. We're having problems with this database. It seems like once every other day or so, it's unreachable for 50 seconds. Well, the great thing is it was a PaaS database. So, Microsoft, what's the problem here? Well, they didn't even see it because they test only once every minute. So they never actually even saw the failure. And it would have been within the SLA that they provided for that service as well. So when someone says it's 3 nines, I assume it's 2 nines, and then write my code to support that type of work. And when things fail, we talked about this earlier, instrument it, log it, alert it, do what you need to do to make your system better. Something as simple as a counter. It's like, I don't think this error is going to happen. You put it into an assert, throw that assert onto a Datadog counter or into Elastic, so you can see it in Kibana or Grafana or something, and then you can go, well, I was wrong. That actually is happening, and it's causing a lot of thrashing on the system. So you want to be able to do that. Here's the big one. Do all of these things and it will be easy. We have really taken the aspect of designing for multi-tenancy. You don't have to in the cloud, but most systems nowadays are multi-tenant, multi-customer, multi-user. It would be very unfortunate if some of those cloud-based games had to scale for every user that they added to the system or every customer. It would crush us at Motorola for every customer we needed. We needed to rebuild the infrastructure. Know how to scale. Multi-tenancy is a great way to be cost effective, but you still want to understand your costs. I put costs this early in the design process for a very big purpose. it's quite possible you've designed a system that doesn't make financial sense. I just left a startup. It was actually one of our problems in our architecture is our minimum cost in AWS usage was about $50,000 a month, whether we had a penny of revenue or not. And there was no way for us to really scale that down to be more cost effective. So it was one of the reasons that we ended up closing that. Actually, we ended up selling off that stuff. So understand cost, understand what the cost dimensions. Is it number of transactions? Is it number of users, number of customers? Whatever it is, you need to understand that. Redundancy is important. This is one of the tools you're going to build to get to that next bullet around high availability. Again, assume a failure is going to happen. A pod is going to go down. It's going to get reallocated to a different host. A VM is going to go down. A network connection is going to go down. How do you maintain that availability? As you're designing for availability, another aspect that cost comes into. Just to get you from a 3 nines to a 5 nines architecture by using some of the blueprints that Microsoft and Azure and Google have all published, it can cost you anywhere between 2.5 to 5.5 times to get to that availability number, depending on how you've architected. So think about that very early on. Availability is not something you attach to a system. It's something that comes out of a system from the very beginning. Think about your storage strategies. Do you need a relational database? Do you need a multi-regional replicated, highly available database? Do you need a document store? Can you get away with blob store, cold storage, hot storage? Use the right solution for the right type of data. It will save you money. It will probably simplify your ability to get access to data. Assume your endpoints are going to move. Someone's going to call themselves endpoint1.com today, and tomorrow they'll be endpoint 2. You have to have a way of being able to manage that. Inside of Motorola, we have a WICD service, well-known ID service, where people can actually reference. That was great until we moved the cheese on that one. We renamed the URL, and all of a sudden everyone broke. But just an example of a strategy on how you can manage some of these dynamic endpoints. Loosely coupled with your dependencies. Again, it's a pretty common design practice. Decouple from your databases. Use asynchronous patterns. I probably overuse queues to keep my front end and my back end independent. It helps with retries. It pushes some of that complex logic deeper down, where you typically have more compute, aren't bound by transaction or connections, things like that. So decouple, find a way to recover when your dependency isn't there. Shared services, obviously you think about the PaaS services, or you might have an internal platform like we do at Motorola Solutions, but you may be a shared service. One of the hardest part about being a shared service is understanding how people are going to utilize you. Again, know your customer. But now for us, we have those 300 some odd projects. Each one of those may use our platform in a slightly different way, may have different scale dimensions. One may have these large multimedia files that it needs to upload on occasion, or another one may have just this fast pounding stream of text. So understand what your utilization is, and make sure that you know how you're going to be able to scale. This is one that I like to advise teams. Think about your ingress and egress to your environment. I try my best to have one way in and one way out, one ingress point and one egress point. One will simplify your security monitoring tremendously, and it will show something in your environment that sticks out. If all of a sudden something is over there and it's using port 80 and it's not coming through your normal ingress point, you know something's going on and you need to go investigate that. So all of that. Be courteous. You're sharing systems, you're sharing resources, could be databases, could be Ingress. Use simple protocols. This used to be a bigger problem. It still happens every now and again. You hear about this in the cloud, the noisy neighbor, where some VM is sucking up some extra CPU and the host is letting that happen. It doesn't happen as much as it used to, but my previous company, given we had these huge compute machines, and we'd roll out 75 or 80 of them, and 4 or 5 of them right at the beginning were duds. Their throughput was down and all of that. So we just reprovisioned them and brought them up to speed. But we always blamed our noisy neighbors on that one. Zero downtime deployment. Again, depending on who you are, this may be critical. If you have a 5.9 system, you can't be down for deployment. It just, you know, unless your deployment takes a millisecond, you can't be down. And this goes back to that automation and hands-off operations and deployment and all of that. So again, these are just some of the things that I'd like to start engineering teams off with. They're not answers, they're discussions, they're architecture, the things that you think through. But we have found the earlier we can have this conversation and partner with teams to start whiteboarding and discussing strategies around it. You know, when is it better to use IoT versus event hubs versus queues? There's a lot of different reasons. When is it better to use a third-party solution? Maybe Kafka is the right solution for you. So this is why you want those in early. You don't want to find out incompatibilities with your platform. You know, we didn't even talk about multi-cloud. Is multi-cloud a challenge for you? So that will change your design, and you need that decision very, very early in your architecture as well. So with that, oh, look at me. I hit my 45 minutes, which is what I had planned. So that was good. I will check chat here for questions, but but again, thank you, Silicon Slopes. Appreciate it. Look for us in, I believe it's 2 weeks, September 22nd. I think it's my boss, Alam Ali, will be talking to you about the journey to the cloud. And here are my 2 obligatory links, so don't hesitate. And Bree is letting me know we currently don't have any questions. So with that, I thank you, and off to the cloud.